Guten Morgen. I'm Insung Yang from KISA, KRSOT. It is an honor to have this opportunity to introduce my presentation to DeepSec conference. The topic of my presentation is Obfuscated Financial Fraud Under Malware, Detection and Behavior Tracking. Let me introduce myself. I'm Insung Yang. I've been with KRSOT KISA for 5 years and in charge of mobile malware analysis. I'm going to give you a brief outline of my presentation. Trends of financial fraud under malware in Korea. I'll try to cover the most recent under malware cases and some interesting older ones. Method of dissemination, types of malicious apps, how to leak victims' data. And we explain more cases of obfuscated under malware to evade detection in Korea. Also, we explain about hackers' remote control behaviors, and we introduce our detection and instant response by KRSOT. It's about mobile malware evolution report from Kaspersky. Left side, number of new malicious mobile program statistics in 2015 a threefold increased from the previous year. Right side, this is number of mobile bank trojans in 2015 detected mobile bank trojan in 2.6 times less than previous year. By the way, the number of attacked countries is growing. Attacks by mobile banking trojan were registered in 137 countries. This case is about SMS phishing in Europe from FireEye report. These campaigns in Europe use view over 8 techniques to present nearly identical credential input UIs as seen in benign apps. Subsequently, tricking unwary users into providing their banking credentials. This image shows the process of how these overlaid malware spread via smishing and impact on the users. This slide presents obfuscation techniques of one sample in the Denmark campaign. With the obfuscation, the manifest file became harder to read and the code structure looked totally different. Okay, the number of South Korea population has crossed over 51 million. Further, the number of smartphone banking users has surpassed 68 million. The data shows that 134% of the South Korea total population. Financial institutions typically implement several level verifications when a user wants to carry out a money transaction. Check ID card information and certificate files issued by financial institution, security number card, and one-time password that is generate a different number every minute. Two-factor authentications like automatic response system and SMS. Financial institution continuously will strengthen security service in order to prevent attacks. This is timeline about trends of financial fraud mobile malware in Korea. Since 2012, bad guys have aimed to steal financial login credentials from smartphone users. And other malicious apps aim to bypass the antivirus protection and two-factor authentication. In 2014, bad guys did intelligence evolve attack. They used malware to connect with phishing. Nowadays, malware app is more sophisticated and have various obstructing ways for reverse engineering. This is phishing side. Since 2004, as phishing attack begins, in 2007, through the classic farming attacks to change the host file has been evolving constantly. Change to the host file from the Internet Explorer hooking, VPN tunneling, compromised DNS, memory patch, using a home router vulnerability. Recently, bad guys use proxy autoconfig file to steal victim banking credentials. First of all, I will talk about financial fraud malware dissemination. In this picture, some candies are disseminated free of charge through the sky. As you know, bad guys usually use social engineering methods for dismantling the malwares. Before I start, I want to explain how do bad guys impact victims' device. In Korea, most of all attack is smishing. Smishing is a form of criminal activity using social engineering techniques. For instance, hackers select target and collect member phone numbers. Second, disguise app as normal is disseminated to members by SMS. So when victims click the URL in SMS, Malware app is downloaded, and after install, your smartphone data is stolen. This slide explains fake validation process. After sending smishing, bad guys demand victim their phone number input the phishing site. If hackers database server have that number, victim smartphone will download financial fraud malware from hacker's server. This app shows recently masqueraded as the official apps in Korea. Hackers are using real icons of famous company apps. For example, Chrome, other Flash, and this mobile imitation, and domestic capital company, and domestic delivery service, and domestic prosecutor's office. This is one of smishing recent cases in Korea. Bad guys are sending SMS phishing to lure people by point gift. When users click SMS URL and connect to phishing site, the bad guys request to type a name and phone number via phishing site. When fake app is installed, the malware requests victim to input name, social security number, selecting card company, or card information. This is another case. In April 2014, the Seoul ferry in South Korea had completely overturned in an accident resulting in the death of 295 people and 9 people missing. People were waiting to hear the news about survivors in the accident. So bad guys made disguised news articles and smith message to people. Hackers also had compromised the well-known website. The bad guys found web servers both upload Novelty, file which having GUI header signature is uploaded, but the file is actually one-line web shell. And bad guys actually additionally upload to compromised web server, mobile, and PC malware. So they disseminate mobile and PC malware to different victims by same server. For instance, online bus ticket booking site, when a smartphone user attempts to make a connection with that site, Malware app was naturally downloaded. It seemed to be normal app. As you know, Malware app have been disseminated by the official map market. For instance, some apps could easily mention your credit card information in single app. However, the information is not encrypted, and this data is sent to a hacker server. Hackers also uploaded Malware app disguised as movie The Interview to troll sites. Fake the interview app was really under banking malware. Malware app have also been disseminated through SNS such as Twitter. Nowadays, bad guys have attacked IoT-based home router. After they successfully exploit vulnerabilities in a home router, they put the router's DNS server setting to their IP address. If victims not only access popular portals in mobile, but also access those sites in PC, malware is installed for steal their financial login credential. Recently, hackers induced victims to input their personal information like a social security number, name, date of birth. Hackers steal that SMS authentication number. Finally, they get victims' portal account ID and use it for viral marketing. Second, I will talk about types of malicious apps. In this picture, we can see different kinds of tropical fishes. I will discuss the evolution of financial malware in detail. In March 2013, bad guys began to steal victim certificate file in smartphone. In May 2013, Drop app, the app includes 8 app files in SF folder for additional installation. In September 2013, installed malicious app tried to download new malware from pre-made hacker server. In January 2014, call forwarding ARS authentication of incoming calls will be forwarded to the bad guys. Victim will not be able to know incoming call. In April 2014, as I said, fake credit card major app have been dissemination in official app market. In January 2015, hackers made different way to steal victim security card. They make victim scan only one shot picture of the security code using a smart camera. And since August 2014, this disguised as a loan app requests victims to type their salary and name, date of birth, contact detail. It is actually be connected voice phishing attacks. Second case, bad guys. This is second case. The second case, bad guys explained that personal identification was needed before running the message application, and a call to confirm the identification will be directed to the user with the indicated phone number. The malware monitors text message and outgoing calls and directed call message, call history. We are going to explain mobile APT. First, spy software is used the sound recording function without knowing and could trace victim's location without the prior consent. And hacker also attempt to steal chat logs of mobile messenger which is widely used in Korea. In addition, sextortion cases in which anonymous men are tempted via video chat. If a victim didn't pay requested money from bad guys, it sent the recorded victim's nude image to their friends and family. Bad guys also make malicious apps to bypass antivirus. Fake antivirus UI is found when running the banking app. Malicious app is stopping normal process if antivirus is running. Bad guys also have found a way to inhibit the installation of antivirus. Fake antivirus is installed with the same normal package name. Indeed, normal antivirus shows the UI for the same. The malicious app actually removes normal app antivirus. As you know, the hackers are continuously aiming to bypass the antivirus detection. Third, I will explain how to leak victim's data. In this picture, the guy tried to complete his impossible mission. Now let's look at how hackers leak at the victim's data. General hackers connect infected device with pre-made server and upload victim's data to their server by HTTPS as well as FTP. And this case was one of the interesting cases. Evolve malicious app posted the victim's data to hackers' pre-made BBS without knowing. The uploaded data was locked by unknown password. Hackers are using email account to steal victim's data via SMTP. The email account is hard-coded in source code or raw file. Even C2 server and email account is included in native code, also known as SOAP file. As shown below left, typed credential data is stored in a local, and these data are compressed and sent to hacker's email account. This is credential data, and this is certificate files. Okay, I will talk about obfuscated Android malware in Korea. This is timeline about obfuscated Android malware in Korea. First of all, Google provide obfuscation service ProGuard, and since 2013, bad guys hide their additional malicious behavior to raw and asset files. They encrypt C2 string using DES and AES algorithm for anti-reversing. After that, they include another encrypted DEX file in APK. And they put their main malicious code to native library file by JNI. Since 2014, they begin to use APK Protect. It's difficult to analyze than before, but we can decode automatically. Nowadays, bad guys use various commercial packers for anti-reversing. This is just in Korea case and in real life. Let's explain simply one by one. Install malicious APK in the area of resource assets and obfuscated character strings of text files in the area of resource loop were found. This is SF folder, is SF file, and this is also row, and some text files obfuscated. After decoding, we can get some C2 domains. For string obfuscation, the malwares are using base64 AES, DES algorithm, hexadecimal to text. Even the hacker address is changed every day using obfuscation. It was confused, analyzed with obfuscation code, and could be delayed their response. This encrypted text file in asset folder of inside, but it's differently encrypted by DES algorithm. This case is using native code. When you get their hidden malicious code and string in native library SO file by GNI, because it's hard to understand this assembly. According to this case, the malware gets obfuscated C2 string and DES key by GNI. This is DES key, and this is obfuscated the block and block ID. To know the latest trend of obfuscated under malware, the packing rate was identified among a mobile malware samples collected from July 1st to 25. Packing types were identified for mobile malware with the file strings that each packer had in common with the rule value. The result showed the recent packer was frequently used in other of Tencent, Xiaogu, Baidu, and APK Protect. This is about APK Protect. This malware disguised as Google Play in Korea, it was impossible to know the beginning point of static analysis. According to the manifest, APK main app class runs before main activity. APK main app class calls live apk protect.so. It analyzed the native code by using a static decompiler tool like IDA. Even if the protector is removed, certain malicious activities can be detected after the character strings are obfuscated again by using base64 plus DES algorithm to solve this. Still encrypted string, base64 plus DES. These slides show some of the obfuscated strings and the obfuscated strings. Now you are able to see that real malicious code. NQ shield is one of packers when this application runs. The packer make original classes text files via text to load.apk and NQ data in a set. This packer protects this app by NQ shield encrypt solution, so observed analysis. This app actually collects device information like our IMEI and IMSI, installed package name, Wi-Fi MAC address, model SK, and release version. This Xiaogu packer also disguised as an auto-install flash player. Xiaogu packer used their own package name and main activity name. This packer called native library file, but the file actually have abnormal section header. So we can analyze using IDA before recover it. If we recover section header, we can easily see function names in IDA. We analyze GNI unload flow, so find out anti-debugging functions. If we exist trace the PID in proc self status or TCP 23946 port in proc self TCP, then terminate this process directly. When we run dynamically, the malware requests to input personal information. When you see the malware that uses bunker packer, the text file is encrypted. Malware decodes the bunker classes .jar file in the SS folder of the application, loads it in the memory, and conducts malicious activities. It copies the encrypted classes .jar file and JNI library file, and also credits child process. This is encrypted text file in JNI for decryption. You can see from class A core that JNI library is loaded for decoding. The decoded text file is run by my class loader at util.run package in the end. You saw the malicious text file go to memory after decoding, and this memory dump was used to extract the decoded text file. If dumped binary files are analyzed with the memory dump, the magic number of text file can be identified. When this is modified to the text format, the text file can be decompiled. The image on the left shows the structure of original text file. When you use the memory dump, you can see the major malicious activities and service, such as information steal from the user device, call recording, and position such as GPS. The malware that spread via SMS phishing, also known as smishing, and websites in Korea use Tencent packer many times. In this case, they pretended to be a package delivery service. The files on the left are configured to load normal text only when they run and include necessary files. There is the main activity of the application beginning position, but we cannot see it as it is packed. This is Tencent packer file structure. This is manifest file. We are able to see the malicious activity, service, and receiver at the Android manifest. The malware asks for the device administrator, and if we try to deactivate the device administrator, it interrupts with an alarm. The malware icon disappears and it runs with the background service. We can see that C2IP is saved at the shared preference file. The actual packet also told us that the phone number of the infected device and information of the telecommunication service provider have been leaked. I will talk about malware behaviors controlled by bad guys. I will explain the cases of receiving a C2 address by accessing a specific blog. The first case involves Qzone, which is a social networking website created by Tencent and one of China's major blog sites. This code is part of decoding process of obfuscated strings. This obfuscated string is decoding module, and then we can see the Qzone blog, the site, with the user ID. As shown on the right screen, specific string values of alphabets are passed in the background, changed to a C2IP address, and stored in shared preference when it is executed. If this IP address is blocked, from being connected at the ISP level nationally, the hacker can dynamically change the address to a new one without having to redistribute the app again as the block is used. The malware apps connect the block and then get the obfuscate string and decrypt the obfuscate string and make H2IP. So saved in shared reference file. Second is Taobao, a Chinese website for online shopping. In this, the code is supposed to connect to a specific item address of Taobao when a malicious app is run. The H2IP address is obfuscated by hacker in advance by using specific Chinese characters, which are passed and inserted into the part of web page that starts with data title. It's data title passing. It's Taobao blog site URL, and then connect and get the Chinese character string, so make H2IP. So this case is Baidu. This is to access the profile information of a specific user in a Chinese search website and pass the strings. As explained in this previous slide of Qzone and Taobao cases, it is similar in that all the obfuscated strings are inserted and decoded. This was obfuscated in numbers, and this is passing keyword. Also make after make the H2IP and save it. This is a little different one. This malicious app put important strings such as Baidu access address, profile ID, profile ID, and that's algorithm key in the native library source file. As I mentioned, this is the blog site. Actually, the blog site was encrypted, and this is the blog ID. So, malware can select the different ID when the IP is blocked. And this case is this also obfuscated string. This Baidu site is same the user ID. Also, this is the obfuscating string. In other case similar to Baidu, in this case is about Downblog, a Korean search website. In the code, the hacker has access to the blog profile of Down and get a numeric string encrypted using AES. The strings are decrypted in the native library at runtime. Very similar to Baidu case. This section explains how hackers control the system by sending SMS. Notably, when an SMS is received, a receiver should be registered and the permission should be defined under a manifest XML file. Hackers usually need victims' SMS to bypass the authentication process or steal information by intercepting the authenticated text context. This is just prefix. When hackers send SMS, the malware need to separate the hacker's command. So this is keyword. The text contains malicious code that delete the text contents sent by hackers so that infected users are left unaware of the infection. The text strings at the right of the slide shows prefix keyword in malicious apps assigned by hackers in Korea. When the user receives hacker's SMS, they use the prefix keyword. Yet another case involves hackers sending instructions to users by SMS, in which blog URL addresses obfuscated by this algorithm and base64 are stored in the native library file in advance. When a sheet to that is passed from one blog is blocked, it connects to another blog, patches on active sheet addresses, and it inflicts damage to the users. A GBA and GBB and GBC, GBD, GBE is actually GBA to GBC is encrypt address information in the SO library file. And GBD is the keyword that get comment deletion of the impacted the device's message. And this is also key, that's key for decrypting. Recently, hacker made financial fraud malware for voice phishing attack. As I mentioned, if victim tried to call financial company, hacker to redirect to voice phishing number. In this case, C2 string was obfuscated. This obfuscated, and so it's decoding model. So we can find out the C2 IP. And the victim received numbers for monitoring from hacker server. This monitor number. So hacker can change the monitor numbers if bad guys want. In this slide, this logic shows that this malware sent victim's device information to G2 server, and bad guys remotely changed monitoring phone numbers by this malware. Right side shows that victim's data are leaked to hacker server. Now we explain how we detect and contact and track mobile financial fraud malware. First, against phishing, we detect SMS messages that are distributed as spam to anonymous users, analyze distribution URLs and malicious apps, and block the discovered C2 IP according to ISP. Second, we monitor and respond to the websites by applying detection patterns and rules to modify the application. Third, we respond to distribute malicious apps when we identify the mobile web page attempt with. Third, we collect automatically and systematically malicious activities from newly registered apps in the official market. We classify the app based on obfuscation, packing, and unpacking for possible apps. We then classify the apps again according to detection pattern for suspicious malicious app. Further, we detect zombie mobile phones which are still untreated and untended by mobile vaccine. Attempting to connect to C2 of malicious apps, we send a notification to the identified users about the treatment to remove malicious apps. In Android, there is a risk when you install apps outside the official market from unknown sources. We discussed a policy on this issue with the mobile phone make vendors and telecommunication companies and changed the default settings so that if necessary, only one installation is allowed. Under special circumstance and other installation are not allowed for this app. I'm going to point out our response by the architecture. First of all, the malicious apps was collected by smishing, spam, SMS, and report. In the market monitoring system, we do not only share about C2 IP address, ISP, but also open communicate with security company for cyber intelligence sharing and protection. Further, we are conducting research on the notification and cure process for victims who have not identified malicious app infection. Is just recalling the spam SMS or report the shortened URLs, and it's internet, it's compromised web server, official and black market. So we do analysis and verification that is malware or not. After that, we try to find out just infected devices and push notification. So I will talk under malware analysis system. First of all, we collect new webs by Google Play Store, domestic official market, one store, virus total intelligence, black market, malicious URL. After that, we classify packer type, and we try to recover that files if possible. In statistic analysis, we compare malicious app and similar abnormal app. So we find our similarity between that apps by SSD and image resource. And after we also understand obfuscated function of similar type, we apply the decoding logic in the system. So we can decode all sample by one decoding model, but we need to understand that logic, but sometimes very difficult to understand. In dynamic analysis, we extract 32 behavioral information, we provide the log time order. In tracking behavior, we select malware and we monitor specific event, so we find out new change C2 easily than before. We classify crawling app to whether packer or not, so we can separate by specific packer, pattern of Yara rules. And this is Yara rule for classification, the packer type. Yes, we separate what this app use packers. This Xiaomi and Xiaogu and APK Protect, Bunker, and Tencent. We can identify. And in static analysis, we check similarity between two apps. We can group malware family and detect variety malware. In this case, we choose two financial fraud samples found via SMS phishing this year. SSD similarity is 44%. This slide shows when compare resource images between two apps, similarity is 91%. That apps are only different launch icon and text file. We can guess same hacker made it, and we can find easily the same family. Last thing I'm talk about tracking behavior. It's one of our challenges. As I said, some malware are getting hackers comment via site, blog, SMSs, change to new obfuscated C2 strings. Download of additional apps, change monitoring phone list. We can monitor behavior of infected devices using real area in under application framework. So we collect specific call, SMS, internet event logs. And if systemically detect important signal, the system noticed by email. Let's summarize briefly what we have covered. Most of financial malware was designed for smishing in Korea. Even nowadays, is other countries also. And bad guys continually disseminated by various ways, such as smishing, compromised web server, a home router. Nowadays, while the number of financial fraud apps is decreasing, their obfuscation technique continues to evolve and become more complex, especially malicious app authors apply the latest version of commercial packers to interfere, to obstruct with the analysis of malicious app. In the past, minus F usually comprises a single sheet address. However, these days it includes multiple addresses, multiple sheets to bypass the IP when it is blocked so that it can be continuously used. In addition, the app contains functions to change new IP address using blogs and SMS, even to change outgoing call list of monitoring. We are trying to classify obfuscation pattern of commonly used mobile malwares based on the information collected by the system. And we need to keep track of behaviors of malware app and take immediate action against hackers' new behavior. Thank you for coming. Have a great time in Vienna.
The problem may be that communication is difficult concerning language, so we try, but if things stay open, you can contact him via email.
Thank you for the interesting presentation. We have similar problems in Austria with Android devices. So I wonder, do you have some statistics to show how big the issue is in South Korea?
No.
Question was on statistics. Do you have statistics?
You mean nowadays is problem in Korea?
Yeah.
It's same, just smishing cases, and just it's difficult to unpack the real code. We tried, as I said, they used the malware authors used a lot of packers latest version, so. We need to
maybe we take the discussion to email because even if he has statistics, you won't have brought them. So maybe you exchange emails and yeah, because it might be interesting
if you need some more detailed information or
yes,
you have, just send an email. So I will have.
Okay.